Today, we're going to talk about data representation in computers. And this first lesson, which is parts 1 and 2, we're going to talk about how characters or words are represented in our computers or devices and images. And then next time, we're going to talk about how numbers are represented. So how is the data that we use represented inside computers? Well, it's actually represented by ones and zeros, what we might call binary or bits. So what is binary and why binary? Okay, so computers are electrical devices made up of a complex system of electrical wires. Think about it. We have to charge our phones. We have to charge our computers, our iPads. Okay, so they are electrical. Okay, so and in the simplest form, if you have one wire, then a wire, if it's powered by electricity, can either be on or off. So the simplest message I could send somebody if I only had one wire would be on or off. Say I'm in one room and you're in another and we have one wire that goes between us and I want to send you the simplest message I can. If the wire is lit up, then, or if it has power, it could be attached like a little light bulb. So if it's on, then my answer is yes. If it's off, then my answer would be no. Okay, so that's the simplest form. Okay, and that's what binary is. Anything that can only be two options, yes or no, on or off, 0 or 1. Okay, and a bit is a single binary digit, and that is a 1 or a 0. I'm sure you've heard of bits before. Okay, so what type of data is represented by these ones and zeros or binary? So we're going to talk about, like, as users of devices, the types of data we see are we see text or characters, we see numbers, we do calculations with numbers, we see images, we see colors, we see videos. Okay, so that's what I as the user sees. Okay, but inside the computer, it's represented by ones and zeros. So that's what we're going to be learning about over these next two lessons is what does that look like inside the computer? And this is just a simple introduction to binary. So we're not going to be doing anything too complex, but it is important that you know these vocab words and what how these three different data types are represented. Okay, so first we're going to talk about ASCII. Okay, so all computer systems in the world use the same table, okay, and they assign 8 bits to a single character in the alphabet and all other characters on a keyboard, okay, spaces and exclamation points. And there's even some special characters that might not be on your keyboard, but you still might see them on your screen, and those can be represented by 8-bit ASCII, okay? ASCII stands for American Standard Code for Information Interchange, and this is universally recognized, okay? So the 8 bits of 0, 1, 1, 0, 0, 0, 0, 1 is always the character lowercase a because everyone has agreed it is, okay? So when I type out an email message and I hit send, it goes across the world through all the different computer systems. It ends up on somebody else's computer when they read it. And when their software on their computer puts those characters on the screen, their software also uses the same table. So they're going to see on their screen what I saw on my screen. And that's because everybody's agreed on the ASCII table. Okay, and this is just a representation, a small representation of what the ASCII table looks like. You can see I have 8 bits, and those 8 bits mean the character 0, not the number 0, but the character 0. And then on the right-hand side, you can see that these 8 bits mean all these uppercase letters, and there's different bits for lowercase and different bits for uppercase. There's even bits for the space bar. Okay. So what y'all are going to do today in your assignment is you're going to use an ASCII table, and I've given you that in the assignment. You're going to use the ASCII table, and you're going to decode a binary message. Okay, so you're going to have to look it up. It's kind of like, if you had a secret code with a friend and only y'all knew what the table was, then you could send each other decoded or encoded messages. The other person has to decode it. So that's what our computers do. Our computers only communicate in ones and zeros. So on both ends, I send an email, someone else reads an email, but the way it travels, across the world is in ones and zeros. So on each end, it has to be encoded into ones and zeros, sent across the ocean, and then decoded from ones and zeros into a letter or a character that a human can read. Okay, so that's the first part of today's lesson. Okay, now we're going to talk about images. This is a little bit more complex. So how are images represented by binary? So every photo that we can see on our device is represented by ones and zeros. But today we're only going to talk about the simplest of images, black and white. Okay, so later on y'all might learn more about how colors represented, but today we're just going to do black and white. Okay, and each image is made up of tiny little dots or squares. If you look at the bicycle at the top, it's a pretty complex image, and you're thinking to yourself, I don't see tiny dots and squares, but they're there. Okay, but the image on the bottom is blown up so you can actually see what the pixels look like. Okay, if you were to zoom in with like under a microscope on this top image, you would see all the tiny little dots. Okay, and each of these tiny little dots is called a pixel. Okay, and that contains a single point of color or of a larger image. Okay, and today that color is black or white. So in a simple black and white image like this, black is off. Think about it. If I turn the lights off, it's black. And so that's represented by 0. Okay, black is off, 0 represents black. White is on, so 1 represents white. Okay, and then in addition to our color information, we also need to know the width and the height of the image. Okay, if I only know the bits, then I don't know how to draw the image correctly. Okay, the image, this bicycle image is 16 pixels wide by 9 pixels high. And if the computer doesn't know that, they might just draw all the black and white dots like straight across in a line or super tall. So you have to know the width and the height. The computer has to know the width and the height in order to be able to put those pixels on or off, black or white, on the screen. Okay, so this is just a simple overview. You'll also have these slides available to you, and so you need to finish your assignment. Oh, one more thing. We are going to be in Unit 5, Lesson 4. This is new on code.org. Okay, so I'm going to go to Unit 5, Lesson 4, and I'm going to show you. Okay. So you're on code.org. If you're, like still in Unit 3, you're going to need to go back to the top, go back to all the computer science discoveries, scroll down to Unit 5 and click on that. Okay, so you're going to go to Lesson 4, and it should be the only one available. You're going to click on Puzzle 2. Okay, and the assignment here is to complete the X shape by typing zeros and ones. So I'm going to do Puzzle 2 for you, and y'all are going to do 3, 4, and 5 on your own. Okay, so start over because apparently it's okay. So when y'all come on it, the image on the left is going to look like this, and you can't actually click on anything over here. Okay, and these are my ones and zeros over on the right hand side of the screen. Okay, and my image is 10 pixels wide, and my height is 10 pixels high, and these are my ones and zeros, and they're in what the computer is calling a readable format. It's got spaces in between there, but in the computer it would be in a raw format, and it would just be ones and zeros all the way across. But that's hard for me as a person to read, so code.org's given me the option to put it in a readable format. Okay, and this is where I'm going to type. Okay, so I'm going to go down here, and I want to make sure this is white. Over here, I want to make sure that's white, so I'm going to say 1, and then 0. And as I type it, I can see them turn white. And I can hit return or not return, and then I'm going to hit 0. Make a bunch of ones. Okay. See how I just typed in there? It looks raw. I can click on readable format, and it will make those all turn black. Okay. I can click on readable format and it'll put the spaces in there, okay? So once y'all are finished, so y'all need to do 3, 4, and 5 in here, okay? And then you just finish, click finish, go to the next one, okay? And now you're gonna use what's called the pixelation widget and you're gonna draw a smiley face, okay? So as I type ones or zeros, it's going to, oops. I mean, that's not a, oh, that's not right. That's not a smiley face. Okay, so I can just start over. Okay, so you're going to finish up 3, 4, and 5 in here, and then you're going to answer the questions on the assignment.